Welcome to this episode of Robert's Creative Chronicles. So today, we'll be solving this question which states that find the derivative of the following functions. These are the functions. So solution. So these functions, first of all, you have to analyze the functions before you differentiate it. So let's analyze these functions. This first one, you can see that it is a function of another function. So we have to use that method to find the derivative. This also is a function of another function. In the first one, the first function is x squared plus 4. The second function is the power of 5, which makes it two functions. This one also is 1 minus x squared. The second one is half, this square root. That is raised to the power of half. This 3x squared plus 4x minus 5 is one function. This cube and this root also is another function because this will be equated, the power here will become 3 over 5. So there are two functions, function of a function. So now let's solve. Let's start from the first one. Now, the first one. Now, this kind of function, there are two ways you can solve it. But it's the same procedure, but there's a faster way. You can either differentiate this internal function, which will give you 2x. The derivative of this internal function is 2x. Then you differentiate the outside function to become 5. Then here will become 4. So it will be 5 x squared plus 4 raised to the power of 4. Then you multiply it by that derivative, which is 2x. But then there's another function. This one, there's another method, the longer method. Well, I'm going to teach you the longer method. And this one at the end, we're going to use this easy method to cross-check our answer. So let's go. The second method, which is longer, but it's the same procedure. It's the same thing, but this one is longer. So we'll just substitute this a variable with this function. Maybe we say t is equals to x squared plus 4. Then differentiate t with respect to x. The t over the x is what? Is 2x. That's what we did before. Then, now since t is equals to x squared plus 4, you know that y will be equals to what? T raised to the power of 5. So you differentiate y with respect to x. No, we differentiate y with respect to t, not x. You differentiate y with respect to t, it becomes what? 5 t raised to the power of 4. Now using the chain rule, it's called the chain rule. The chain rule gives that the y over the x will be equal to what? The t over the x times the y over the t. So you see the logic in this chain rule. When the t and the t cancel each other, the y over the x will be equal to the y over the x. So that's the logic they used. So now we multiply them. This becomes what? 2x times 5t raised to the power of 4. And you know that t is what? X squared plus 4. So this will become 2x what? Times 5x squared plus 4 raised to the power of 4. Then this becomes what? 10x x squared plus 4 raised to the power of 4. So this is the y over the x. So this is the final answer. Now, let's use that other faster method. You differentiate this internal one, the core. X squared plus 4 is what? 2x. You see, 2x. Then you differentiate the outside function. It becomes 5x squared plus 4 raised to the power of 4. You see, 5x squared plus 4 raised to the power of 4. Then you times them. So you see that it's the same. This one is just the broader method, the longer, more extensive method. Here is a shorter method. You can use it for OBJ exams or you just differentiate this the one we did at the beginning, it becomes 2x, then you multiply it by 5. That's the derivative of the outside one, 5, open bracket, x squared plus 4 raised to the power of 4. Then you differentiate fast and you get the answer. You don't even need to write anything down. So that's the longer method. So this is the longer method and that's the shorter method. So here's the second one. This also can be expressed in terms of 1 minus x squared raised to the power of half. So now, in this one, I use the longer method of solving it. In this one, I'm going to use the shorter method, so you also become conversant with that method. Now you know that this is the method. If y is equal to f of g of x, then dy over dx will be equal to f prime g of x multiplied by g prime x. Now what I'm trying to tell you is that if you are given a composite function, all the functions given above are composite functions. In other words, they are functions of a function. If you are given those kind of functions, you can differentiate the core, which is the inner function, multiplied by the outer function, multiplied by the derivative of the outer function. So this is the derivative of the outer function, which represents f, multiplied by the derivative of the core, which is the inner function. So in the same way as we did above, we can also do it here. So you know the inner function now is 1 minus x squared. So you find the derivative. So dy over dx. This is usually a faster method. So you find the inner function, the derivative of the inner function. So 1 minus x squared is what? Derivative is 0 minus what? Minus 2x. This is the derivative of the inner function. Multiplied by the derivative of the outside function is what? Half 1 minus x squared. Then half minus 1 is what? Negative half. So this is the derivative. As simple as this. Then you can simplify it further. So this is it. Then we'll put the final bracket. Now we can further simplify it. This becomes negative 2x. Then here, you know, it's negative 1 over 2. So it can be expressed as raised to the power of half. Then this can also be expressed as what? Negative 2x. This half is square root. So we'll say times 1 over what? 2 square root of 1 minus x squared. So you see. So you can see that the derivative of this is negative 2x over 2 root of 1 minus x squared. So this is the final answer. So this is the final answer. This one. This is the derivative of this. So this is also the chain rule. Is a chain rule expressed in another way. It's also the same. This also is the chain rule expressed in a different way from this. But this is the original chain rule. So, but they are the same thing. They mean the same thing. These two. So now let's move to the third one. And please let me tell you that this rule I used here, this quick method I use here should be used for only objective or CBT exams. This T substitution that I did here is the one that most lecturers prefer when answering AC exams because they have marked each of these steps. If one student does this and another one does this, the person that does this will get more mark than this. You can just get maybe 1 or 2 marks here. So make sure in essay do the above one, the one I did above. This one is just for OBJ exams. It's a quick method. It's a very quick method for doing answering CBT or OBJ exams. So in this one, let's use the T substitution method. Or any, you can use any variable actually. I'm just calling it the T substitution method. So 3x squared, this is the same thing as this. Here is 3. According to the law of indices, this is 1 over 5, so you can multiply them to get 3 over 5. So now, this is y is equal to this. So we can say that let t equals to 3x squared plus 4x minus 5, which is the core. And tx is what? Is 6x plus 4. Then this one, y now will be equals to 3 over 5. So derivative dy dx, dy over dx, dy over dt, dy over dt is equal to 3 over 5 t, then 3 over 5 minus 1, which is negative 2 over 5. So here is negative 2 over 5. So now you can substitute it here. So you can substitute the t here before you put it in the equation, or if you put it, you can substitute it after you put it. Anyone. So let's substitute it here. So this will become dy over dx, dy over dt will be equal to 3 over 5 then you put t is 3x squared plus 4x minus 5 minus 2 over 5. So now we can substitute it in the chain rule. So it becomes dy over dx will be equal to what? Dt over dx multiplied by dy over dt. So this becomes what? This is dt over dx, 6x plus 4 multiplied by this. So it's 3 over 5, 3x squared plus 4x minus 5 minus 2 over 5. So this is the final answer. We can leave it like this. Or if you want to, you can still further simplify it. But this is also correct. This is the final answer. So I hope you understood this episode. If you have any question, feel free to contact me using my WhatsApp or email it in the description below, or you can write them in the comment section. Thank you for watching. Please don't forget to like, share, and subscribe to my channel, and hit the notification bell to get notified as soon as I drop a new video. Thanks.